All right, so let's talk about something a little bit different. We've been talking about polynomial equations, polynomial functions, but now let's talk about polynomial inequalities. The good news is at least for your homework, I believe most of these come fully or at least mostly factored. We have, I think, one example we're going to do where we have to factor some, but I looked at the homework and I couldn't find any that that required a ton of factoring. So we got a little break from that at least for now. There might be some more later that do, but for at least these subjects, there's not going to be any major factoring here. It's already factored for us, which is nice. Or at least for the higher degree ones. Maybe you have to factor a quadratic, but we've done that so many times. We have some pretty easy, quick ways to do that it shouldn't be too bad. But let's look at a few examples. Here we have x squared is greater than negative 6x. Okay, so the first thing we want to do is we want to go ahead and find the zeros here. So I guess this one wasn't totally factored, but this will take just a couple of seconds. So here, we can go ahead and bring the 6x to the other side, and we get x squared plus 6x is strictly greater than 0. Okay? And we can write this as, if we pull an x out, we factor out an x, we can get x times x plus 6. And to see how that worked, just FOIL that, or just go ahead and distribute this x back in, and you'll get x squared plus 6x. And then you're going to have this being greater than 0. Okay? So you want to find, the goal with doing these inequalities is you want to find all values of x that make this inequality true. That's what you're looking for here. Anytime you see an inequality, you should think we're looking for intervals here, or probably more than one value is what we're looking for here for this solution. Okay, so let's go ahead. Okay, let's take a look at this when we graph it on a number line. Okay, so let's make a little number line here. Okay, draw a better line than that. Okay, and what we'll do is we'll say, okay, here we have -8, -7, -6, -5, so on, so on. Okay, and we want to figure out all of the values that are going to work here. Okay, so let's go ahead and graph the zeros here. So we know that our zeros are obviously -6 is a 0. Okay, and we know that 0 is a 0 because if we plug 0 in at this x, it makes everything 0. So these are our zeros. So what these two zeros have done is they have effectively divided the number line up into three different sections. So you're going to have everything to the left of this 0, everything in between these two zeros, and everything to the right of this 0. Okay, so that is how we have divided up the number line. Okay, so let's see what happens here. Maybe we can make a little graph looking thing or a little chart here. Okay, so let's plot x and then x plus 6. Okay, and what's really nice here is we can pull sample values from inside each of these intervals here. Okay, product, and we'll see why here in a second. Okay, we can find sample values from inside each of these intervals, and it will make sense for any value inside each of these intervals. Okay, so let's go ahead and test the -8 here and see what happens. So if we take -8 and we plug it in for x, we'll get -8. If we take -8 plus 6, we'll get -2. Okay. So -8 times -2 is a positive 16. Okay, so that means that the product of these two factors here, given a sample value from that interval from -infinity to -6, is positive. Okay, so on the interval from -infinity to -6, the product of these two is positive. So x times x plus 6, for anything on this interval, it's going to be positive. Therefore, anything on the interval from negative infinity to negative 6 is going to be included in our answer, okay? So we know that that is going to be a part of our solution. So we can go ahead and graph this part of it now. So, and since this is strictly greater than 0, we actually don't want to include, we don't want to include that 0. So we're gonna draw an open circle there, and we're going to shade in everything to the left. Okay? So now let's pull a test value from in between our two zeros here. Let's pull a test value from, let's just try negative 3. So we plug negative 3 in for x, we'll just get negative 3. If we plug negative 3 in for x plus 6, we get, so negative 3 plus 6 is going to be positive 3. So 3 times negative 3, that's going to be a negative number. Okay, so the product will be negative. So anything from this interval here, okay, anything from that interval here, if we plug into our factored inequality here, the product will be negative, and therefore it is not greater than 0. It is less than 0. Therefore, we are not going to include this interval in our final solution. Okay, so now we can pull a value from 0 to infinity. So if we pull, say, a 2, all right, we can plug 2 in for x, we get 2. Plug 2 in for x plus 6, and we'll get 2 plus 6, which is 8. So 2 times 8 is 16. That is greater than 0. That's positive. So we know that this interval is going to work as well. Okay. So there we go. For these quadratic equations here, where you have a polynomial of degree 2, I believe they want you to graph these. That's sort of how we're going to do it. But for the rest of these, we're going to use interval notation. Let's take a look at this one. Here we have x minus 8 times x minus 2 times x plus 4, and we're looking for when this is greater than 0. Okay, so let's look at the intervals that this divides our number line into. Let's look at our zeros. Our zeros are going to be 8, 2, and negative 4. Okay, so our smallest number here is negative 4. So we know that from negative infinity to negative 4, that's one of our intervals. Okay, so then we'll have the interval from negative 4 to 2, that's our next highest number. Okay, then we'll have the interval from 2 to 8, and then we'll have the interval from 8 to infinity. Okay, so let's go ahead and list each of these out here. So we have negative infinity to negative 4. We have negative 4 to 2, 2 to 8, and 8 to infinity. Okay, so now let's list each of our factors over here. We have x minus 8. We have x minus 2. We have x plus 4, and then we're going to take their product here. Okay, so if we let's start doing some test values here. Let's pull a test value from negative infinity to negative 4. So if we pull, so really, I will say this: we're not actually necessarily worried about the exact answer here. We're just worried about what the sign is going to be. So we're worried about whether it's going to be positive or negative. So if we pull any value from negative infinity to negative 4 and plug it in for x minus 8, so any value from negative infinity to negative 4, if we take away from it, we know that it's going to be negative. Okay? Same thing for x minus 2. If we pull any value from negative infinity to negative, any value from negative infinity to negative 4, if we pull, say, negative 5 or minus 2, we'll get negative 7. So we know that this will be negative. Okay, if we pull any value from negative infinity to negative 4, not including the point 4, okay, so let's take negative 5, for example. Negative 5 plus 4, that's negative 1, so this will be negative, all right? So all of these are negative on negative infinity to negative 4. So if we take a negative number times a negative number times a negative number, we're going to get back a negative number. So we have a negative number times a negative number, give us a positive number, times a negative number again, makes the number negative again. So the product will be negative, okay? So since we want since we want this polynomial here to be greater than 0, meaning positive, negative infinity to negative 4 is not going to be part of our solution. So now let's look at negative 4 to 2. So anytime you're given something that includes 0, oftentimes it's really convenient just to use 0. So we're going to use 0 here. So if we plug 0 in for x minus 8, we get 0 minus 8, which is negative 8. So we get a negative number. We plug in 0 for x minus 2. Again, we're going to get a negative number. And 0 plus 4 is a positive number. So we'll have a positive number here. And so we'll have the product is a negative number times a negative number. So these two multiply together give us a positive number. Okay, so a positive times a positive will give us a positive. So this interval will make it positive here. Okay, so this interval is going to be included in our solution. So we'll circle that so we remember that. Now let's pull from the interval 2 to 8. Let's try maybe 3, okay? So we take 3 minus 8, we get negative 5, so that will be a negative number. If we take 3 minus 2, we're going to get a positive. We're going to get 1, so this is positive. And if we take 3 plus 4, we get 7. So that is going to be a positive number. So here we get a negative number times a positive number gives us a negative number. And again, a negative number times a positive number gives us a negative number. Okay, so 2, 8 is not going to be part of our solution. Okay, so now let's take a look at the interval from 8 to infinity. So if we pull up, say, 9 minus 8, that will give us 1, which is positive. Okay, 9 minus 2 is 7, so positive. And then obviously 9 plus 4, that'll be positive. So anything from this interval will make all positive numbers. And if you multiply together 3 positive numbers, you get a positive number. So we can include 8 to infinity in our solution. And how we're going to write this is we're going to write this as negative 4 to 2, and we're going to union that with 8 to infinity. So that would be our solution to this inequality. All right, so let's take a look at this one. Here we have 2 minus x. We have x plus 1, and then we have x squared minus 16. So let's go ahead and factor x squared minus 16 real quick. So here we can have x squared minus 16 equals 0, plus 16 gives us x squared is equal to 16. We can take the square root from both sides, and we get x is equal to plus or minus the square root of 16, which is equal to plus or minus 4. Okay, so we have positive 4 and negative 4 as zeros as well. So really this polynomial can be written as 2 minus x times x plus 1 times x plus 4 times x minus 4. Okay, we want this to be greater than or equal to 0. So let's look at how this divides up the number line. So let's write out our zeros. So our zeros are going to be 2. So if we plug in 2 for 2 minus x, we get a 0. We'll have negative 1. We'll have negative 4. And we'll have 4. So since there's 4 of them, this is going to divide up our number line into 5 intervals. Our 5 intervals are going to be, looks like negative infinity to negative 4. Okay. Then we're going to have negative 4 to negative 1. Then we're going to have negative 1 to 2, it looks like. And then we're going to have 2 to 4. And then we'll have 4 to infinity. So we have 5 different intervals we have to consider. So let's write each of our factors here. So we have 2 minus x. We have x plus 1. We have x plus 4. And we have x minus 4. And then we have their product here. And again, we're looking for this to be greater than or equal to 0. Okay? All right, so let's go ahead and test everything in this interval here. Okay, and we'll deal with the greater than or equal part of this at the end here. Okay, so let's not worry about the or equal to part until the very end, and we'll address that in a minute. So here we have the interval from negative infinity to negative 4. So let's pull like negative 5 out here. So we have 2 minus a negative 5. That's going to be it'll be 2 plus 5. So that'll be 7, which is positive. If we have negative 5 plus 1, that's negative 4. So that'll be negative. If we have negative 5 plus 4, that's going to be negative as well. And then negative 5 minus 4, well, that'll obviously be negative. So here we have a positive number times a negative number. That'll give us a negative number. So then we have a negative number times a negative number. That'll give us a positive number. And then we have negative times positive again. That'll give us a negative number. Okay, so the product will be negative. So on the interval from negative infinity to negative 4, that is going to be negative, and we want this to be greater than or equal to 0, so we are going to get rid of that interval. Now let's consider the interval from negative 4 to negative 1. Let's try negative 2. 2 minus negative 2, that's going to be 2 plus 2, that's positive. Negative 2 plus 1, that is going to be negative 1, so it'll be negative. Negative 2 plus 4, that's going to be positive 2, so positive. And then negative 2 minus 4 again, that'll obviously be negative. So here we have a negative times a positive is a negative number. We have another negative times a positive. That's another negative number. But now we have two negative numbers multiplied together, which gives us a positive number. So on the interval from negative infinity from negative 4 to negative 1, we have that it is greater than 0. So we can go ahead and circle this, okay? But remember, we also want it to be greater than or equal to 0. So as part of our actual solution, we're going to write this as the closed interval from negative 4 to negative 1, okay? Because it's a 0, obviously, at negative 4. It's a 0 at negative 1. So we want to include those points. So we're going to write this as the closed interval from negative 4 to negative 1. So now let's look at negative 1 to 2. So we get 0 in this one, so let's plug 0 in. 2 minus 0 is 2, so that's positive. 0 plus 1 is 1, that's positive. 0 plus 4, that's positive. And then 0 minus 4, that's negative. So here we have three positive numbers multiplied together. That's a positive number. Multiplied by a negative number, that's negative. So we are not going to include negative 1 to 2 in here. So now let's take a look at 2 to 4. Let's try 3. 2 minus 3, that's going to be negative 1. That's negative. Let's try 3 plus 1. That's 4. That's going to be positive. 3 plus 4 is 7. That's positive. 3 minus 4 is going to be negative 1. That's negative. Okay. So here we can think of this as 2. We have negative times a positive. That's negative. We have a negative times a positive again. That's negative. So then we have a negative times a negative. We get a positive. So we're going to include the interval from 2 to 4. All right. So we're going to also have the closed interval from 2 to 4. And again, because we want this to be greater than or equal to 0, and so we're going to include the zeros themselves. So we have the interval from 2 to 4. So lastly, we have to check 4 to infinity. Let's test 5. So we have 2 minus 5. That's going to be negative, obviously. Okay, it's negative 3. We have 5 plus 1. That's 6. That's positive. 5 plus 4. Obviously, that's positive. That's 9. And then we have 5 minus 4. That's 1. That's positive. So what we can do is we have a negative number. We have we can do it like this. We have three positive numbers multiplied together. That'll give us positive times a negative will give us a negative. Okay, so we have their product is negative. So we are not going to include the interval from 4 to infinity. So our final answer is going to be the interval from -4 to -1 union with the closed interval from 2 to 4. All right, so there's a brief introduction to polynomial inequalities.